Okay, for problem 48, we are just trying to find the expressions below. So we're given four functions here: f of x, g of x, h of x, and j of x. And what we're being asked to do is find the composition f of g of x, evaluate f of g of 2, sum h of x and j of x, and then find the function h of x divided by j of x. So try to break this up into nice little squares. So if we're looking for f, try that again, f of g of x, well, f of g of x basically just tells us to write f of x exactly as it is, but wherever you have an x, you just want to put parentheses, and then plug in g of x, which we know to be x plus 1. So x plus 1. And from here, we're just going to do our expansion, follow order of operations, which tells us to expand the x plus 1 first. And so we're going to end up with the square root of 4 minus negative 3 times, and x plus 1 squared is x squared plus 2x plus 1. And now we have to distribute the negative 3. So we're going to get, and you can put little equal signs here if you'd like, 4 minus 3 times x squared plus 2x plus 1. And we're going to distribute this negative 3 to these terms in here. And so we're going to get 4 minus 3x squared minus 6x minus 3. Now the only terms that we have that are common are the 4 and the 3. And so we'll add those together, and we end up with negative 3x squared minus 6x plus 1. So that is the value of f of g of x. And so f of g of 2 now basically is just telling us to evaluate the expression we found above when x is 2. So we have the square root of negative 3 times x squared minus 6 times x plus 1. And now instead of plugging x in here, we're just going to plug in 2 and do a little arithmetic and evaluate. So following order of operations, we square the 2 first. So 2 squared is 4 times negative 3. That's going to give us negative 12. Negative 6 times 2, that's going to give us another negative 12. And then the positive 1. And so negative 12 minus negative 12 is negative 24, plus 1 is negative 23. And we know that this is the same as positive 23 times the square root of negative 1. And we know that we have another way of writing the square root of negative 1, which is just I. So it's going to be the square root of 23 times I. And I'll make that a little clearer because that's not the prettiest I. And so that is the value of f of g of 2. All right. So what about h of x plus j of x? So h of x plus j of x. H of x is x squared minus 4 plus j of x, which is x plus 2. Well, the parentheses aren't really doing anything here, so x squared minus 4 plus x plus 2. And so then we have the negative 4 and the 2 that are common terms, so we can add those. So we get x squared plus x minus, oh, didn't even write the x squared plus x minus 2. And so that's the expression for h of x plus j of x. And then our final one is h of x divided by j of x. So let's just put a line here. H of x divided by j of x. And so that's going to give us x squared minus 4 over x plus 2. And hopefully by now you'll notice that numerator is a difference of squares. It's x plus 2 times x minus 2. over x plus 2. And we have the same term on top and bottom being multiplied, so we can cancel them. So we have just x minus 2. And so that is the expression. Now, I'm just going to try to briefly remind you that if I was asking for the domain of h of x divided by j of x, our original expression is going to be x squared minus 4 over x plus 2. And the one we ended up with is x minus 2. So because h of x over j of x originally had this x plus 2 in the bottom, from here we should notice that we can't plug in negative 2, right? Because then it would give us a 0 on the denominator. So from our original work, we have to follow that limited domain throughout the entire problem. So even though we end up with the answer x minus 2, and this doesn't have a domain issue, we still have to respect the original domain issue. So the domain of h of x over j of x would just be negative infinity all the way to negative 2, skip negative 2, and all the way to positive infinity, because our original representation of h of x over j of x wouldn't allow us to use negative 2. And the difference between x squared minus 4 over x plus 2 and just x minus 2, really, if we were looking at the graph, it would just be that the first one has a hole right here at the point negative 2 comma 0, but x minus 2 doesn't. So that's the difference visually to kind of help you figure out what the difference between these two graphs is. So for h of x, j of x, our domain would restrict negative 2, but if we just had this as, call it, let's say, a of x, then this one wouldn't have any domain restrictions, right? It would just be all real numbers. So hopefully that was helpful. If you guys have any questions, feel free to email me or see me in office hours.